Okay, so for number 7, see what you could do on these 3 Lewis structures. And this is how the question would be on the test. It would say, draw a Lewis structure with either an expanded octet, an incomplete octet, or an odd number, or more likely to say, draw it and tell why it's an exception. Okay, so there's one of each here. I didn't necessarily put them in the order that I listed them. Try to make you think a little bit. So I'm going to pause here and catch up on my recordings while you guys see what you could draw on them. Okay, so let's go ahead and look at these. So exceptions are kind of a pain, but they're easier when at least you know it's an exception. So I have 4 minus, iodine has 7. Electrons. Each fluorine has 7 electrons, and then the -1 tells me I've got 1 more. So 4 times 7 is 28, 29. I've got 36 electrons here. And so if I go ahead and stick the 4 fluorine on with single bonds, again, using the same process as we've used for all the other structures. So that means each fluorine still needs 6 more electrons, or 3 pair. So now when I count up, I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And this is where some people messed up on the quiz. This isn't -4. This is +4. I'm not short 4 electrons. I've got 4 electrons I have to put somewhere. A double bond isn't going to help this. A double bond is going to make even a bigger mess. So if you get a positive, you have extra electrons, you have to expand your center atom. You have to expand its octet. This will only happen with something in period 3 or bigger. I can't expand the octet for fluorine because fluorine's too small. It's only a level 2, a period 2 element. But iodine has a d orbital. You could throw those extra electrons into iodine's d orbital. Okay, so that's an expanded octet. More than 8. Is that as stable as if it had a regular octet of 8? No. But it's more stable than fluorine or iodine are on their own. Fluorine and iodine are really reactive elements. So IF4 minus is still a lot better. NO, 5 plus 6, we have 11 electrons. As soon as you get an odd number, first thing I do is double check my math. But if you know it's an exception, then you know the best you can do is 8 on all the atoms except the center one or one of them, and that one's only going to get 7. So I go ahead and draw N, connect the O. If I had enough electrons, these would each need 3 pair. That would be 2, 4, 6, 8, 10, 12, 13. How did I count? 2, 4, 6, 8, 10, 12, 14. I got odd on my. So that's 3 electrons. So 2 double bonds is too much. 1 double bond's not going to quite take care of it, but 1 double bond will make it better. Okay, so now 2, 4, 6, 8. So now what do I do about the fact that I still am using 2, 4, 6, 8, 10, 12 electrons, and I only have 11? It means I just have to take one off and leave either nitrogen or oxygen short an electron. It would actually be nitrogen. Anyone know why? Which means it's also less electronegative, yeah. It would be the central atom if there were more than just 2 atoms, but we list them left to right from least electronegative to most. So that means oxygen is going to have a stronger attraction for the electron, so it's definitely going to get its 8. Again, that's not a huge deal. Yeah, so if there's an exception, if there's too many or not enough, you try to make the exception happen on the center atom, because then it keeps the rest of the atom in balance. So if fluorine was able to expand its octet, that would make 1 fluorine way out of balance, whereas this way we've got iodine expanded, but the 4 fluorine around it are identical. And then BeCl2, boron and beryllium, they're little like oxygen is, like hydrogen is, Beryllium only has 2. The 2 chlorine each have 7. So I've got 16 electrons total. So this is one, you just have to remember that beryllium is so small, it can't make a double bond. Why not? Because by the time you made a double bond, the chlorine would be right on top of beryllium. Those 2 nuclei would be so close, it's not going to happen. They're going to repel each other. So 2, 4, 6, 8. I'd want to put 2 here. I'd want to put 6 here. So in an ideal world, I'd either have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'd have 20 electrons so that beryllium could have a full octet. But because it doesn't, it actually will not form. It won't do like we expect it to. It won't form the 2 double bonds. Even though, even though it appears to make it stable, because now I only need 2, 4, 2, 4, and beryllium has 8. That doesn't exist because beryllium's too small to let another atom move that close to it. So instead what would happen is beryllium would just go without those other 2 pair. That's more stable. How do scientists know this? You know, they have equipment where they measure it. They measure the amount of electronegativity, the amount of charge they feel, and they realize that there's not the double bonds, or they can measure the bond length. They measure how much energy it takes to break that bond apart, and it's not enough for it to be a double bond. So experimentally, they have found out this is how it seems to operate. In a second.